Hello everyone, and in my previous video I have told you how to solve the problems based on wave equation. Okay, and in that video I have already told you that in this video I am going to tell you some different type of problems, basically which is essential for B.Tech and B.Sc Physics honors students. Okay, so let us see how to solve these problems. Okay, so the dear number solution of this wave equation utt is equal to c square into ux. That means del square u by del t square is equal to c square into del square u by del x square. Where x is a real number and t is greater than 0. In this case, the initial displacement is f of x. That means u of x0. It is the initial displacement is equal to f of x. And ut of x0, that means del u by del t. Del u by del t means the derivative of u with respect to time. It is the velocity. And at time t is equal to 0 means initial velocity is g of x. And the initial point and the final point, both the end points are fixed. So according to D'Alembert solution, u of xt is equal to, that means u of xt is the displacement of this string at any point x at the time t is half of x plus f of x plus ct plus f of x minus ct plus 1 by 2 c integration of g of y dy from x minus ct to x plus ct. As I have told you, y is the dummy variable. So in place of y, we can take capital T or alpha, beta, gamma, anything, because this is a definite integral, so it does not depend upon the variable. Okay. So see here, one question, and this question is given in the book of physics honors students. Okay, a string is stretched. A string is stretched and fastened to 2 points L apart. That means the two ends are fixed and both the two ends are separated by distance L. So motion is started by displacing the string in the form of y is equal to a sin pi x by L. And this is the initial displacement. Initial displacement from which it is released. That means the string is moved certain distance and then it is released so that it will vibrate. Okay, that means at time t is equal to 0. That means initial displacement. So that the displacement of any point at a distance x from one end at time t is given by y of xt is equal to a sin pi x by L into cos pi ct by L. And this problem I am going to solve by the method of D'Alembert's equation. Okay. So ytt is equal to c square into yxx. In place of u, I am taking y because in the question it is given in the form of y. So here the two ends are fixed. That means y of 0 t is equal to 0, y of L t is equal to 0. And the initial displacement f of x, a sin pi x by L, a sin pi x by L, and the initial velocity is 0. Okay. So what is the D'Alembert's equation? Y of xt. Don't write u of xt here. According to our question, it is y of xt. Okay. Half of f of x plus ct plus f of x minus ct plus 1 by 2 c g of t dt. Because in the question it is given in the form of y, so that is why I am written g of capital T dt from x minus ct to x plus ct. Okay. And since the initial velocity is 0, so I have taken g of t as 0. Here. Now, here f of x is equal to a sin pi x by L. See here in the question, f of x or a sin pi x by L. So f of x plus ct is equal to a sin pi x plus ct by L, and f of x minus a sin pi in place of x I have written x minus ct by L, and this quantity becomes 0. Second term. Okay. So see here, a I have taken common. This a I have taken common, so it becomes a by 2. Clear? Now I have separated pi x by L plus pi ct by L. This also I have separated pi x by L minus pi ct by L. So this is in the form of sin a plus b plus sin a minus b. Sin a plus b plus sin a minus b. That is 2 sin a into cos b. 2 sin a. A is pi x by L into cos b pi ct by L. So 2 to cancel out. It remains a sin pi x by L into cos pi ct by L, which is which you have to prove in the question. See here, in the question it is given that you should prove y of x equal a sin pi x by L into cos pi ct by L. a sin pi x by L into cos pi theta by L. But in other method also you can solve, but this is the easiest method, so that you can solve it quickly. Okay. See another question. A tightly stressed string with fixed ends, x is equal to 0, endpoints x is equal to 0 and x is equal to L, and x is equal to 0 and x is equal to L, both the ends are fixed, is initially in a position given by y is equal to y0 sine cube pi x by L. This is the initial displacement. If it is released from rest from this position, then find the displacement y of x t. Released from rest, that means initial velocity is 0. See here, ytt is equal to c square into yxx. This is the wave equation for the stress string. Since the ends are fixed, so y of 0 t is equal to 0, y of L t is equal to 0. And initial displacement, it is given f of x on y0 sine cube pi x by L, y0 sine cube pi x by L, and initial velocity g of x is equal to 0. So that is the second term. See here. In place of g of t, I write 0. So the second term vanishes. Now f of x plus ct, it will be y0 sine cube pi in place of x, I am writing x plus ct by L, plus y0 sine cube pi x in place of x, I am writing x minus ct by L. Clear? So y0 I am taking common, y0 by 2 sine cube. This one I am separating pi x by L plus pi ct by L. This one is pi x by L minus pi ct by L. So I am applying the formula sine cube theta. See here. Sine cube theta, the formula is 1 by 4 3 sine theta minus sine 3 theta. This formula I am applying. See here. Sine cube theta 1 by 4, I am taking 4 common. Here 3 sine theta minus sine 3 theta minus sine 3 theta. Clear? Second part also same thing, 1 by 4, that means 4 I have taken common. 3 sine theta, here theta is in the form of negative difference, minus sine 3 theta. Okay, see here, this one is 3 sine this one is 3 sine this one, and these two I have combined here. Okay, and this term, second and fourth term I have written here. Okay, so now taking 3 common from these first two terms, I have taken 3 common. Then sine a plus b plus sine a minus b, sine a plus b plus sine a minus b is 2 sine a into cos b. 2 I have taken common, so that 2 to cancel out. Sine a into cos b minus, I have taken minus common, sine a plus b plus sine a minus b. Sine a plus b plus sine a minus 2 sine a into cos b. 2 I have taken common, so that it cancel out with the 2, so remain 4 sine a into cos b. So this is your answer. Okay. So if we will apply the D'Alembert solution, it will become very easy. See here, 4 to 5 times. Within 4 to 5 times you can solve the problem. Okay. So if we will apply the general method, it will take 2 pages or more than 2 pages. Okay. So see here. Another question. A tightly stressed string of length L with fixed ends is initially in equilibrium position, and it is said vibrating by giving each point a velocity v0 is equal to this one. That means it is the initial velocity, and it is started from position of equilibrium. That means initial displacement is 0. Find the displacement y of x t. See here. Here the initial displacement f of x is equal to 0, and the initial velocity g of x is equal to v0. It is given here, v0 sine cube pi x by L. v0 sine cube pi x by L. So see here. Here the f is 0, so the first term vanishes, only the remain the second term, 1 by 2c in place of g of t. See here, in place of g of t, it is v0 sine cube pi x by L. In place of x I am written t, pi t by L into dt. Here, see here, again v0 I have taken common, and sine cube theta. Sin cube theta. The formula is sin cube theta 1 by 4 3 sin theta minus sin 3 theta. So 1 by 4. 4 into 2, it is 8. 8c. 3 sin theta. 3 sin theta. Theta is pi t by L. Minus sin 3 theta. 3 into this one. 3 pi t by L. So integrating. The integration of sin mx. Integration of sin mx is minus 1 by m cos mx plus constant. Minus 1 by m minus 1 by m. Here m is pi by L. So it will become L by pi. 3L by pi cos pi t by L. Again sin mx, that means minus cos. It will become plus. Minus minus plus. L by pi, because it will be 3 pi by L. So it will be L by 3 pi. Okay. Cos 3 pi t by L and x minus c to x plus c t. So put the values. Simply put the values. See here. I have taken L by pi common. L by pi outside. Okay. So minus 3 remain. First put the upper limit. In place of t, I have written x plus ct. Pi into x plus ct by L. So pi x by L plus pi ct by L. Clear? Again put the lower limit here. In the first term. 3 cos. 3 cos minus 1. Upper limit minus lower limit. So minus 1 is plus. Plus 3 cos pi x by L minus pi ct by L. It is given x minus ct. And in the second term, see here. L by pi I have taken common. So 1 by 3. 1 by 3 cos 3 pi t in place of t like x plus ct. So 3 pi x by L plus 3 pi ct by L. Again upper limit minus lower limit. It will become minus 1 by 3 cos 3 pi x by L minus 3 pi ct by L. So taking 3 common from these two terms, it becomes cos a minus b minus cos a plus b. Cos a minus b minus cos a plus b. See here. See here. Cos a minus b minus cos a plus b. It is 2 cos a into 2 sin a into sin b. 2 sin a into sin b. I am writing the formula. Cos a minus b minus cos a plus b. Equal to 2 sin a into sin b. Clear? That formula I am applying. Cos a minus b minus cos a plus b is 2 sin a into sin b. Clear? So in the second part, see here, cos a plus b minus cos a minus b. Cos a plus b, it will multiply negative. Cos a plus b minus cos a minus b, it will become minus 2 sin a into sin b. Minus 2 sin a into sin b. So minus 2 sin a into sin b. Clear? So I am taking 2 common. 2 by 3. I am taking 2 by 3 common. So it becomes 12ct. Because 2 and 8 will cancel out. It will become 4. 4 3 is 12. And this becomes 9. 9 sin pi x by L into sin pi ct by L minus sin 3 pi x by L into sin 3 pi ct by L. So this is the final answer. So if we do this question also, it will become 2 to 3 pages in the general method. Okay. So try to apply the D'Alembert solution while solving the OM equation so that it will become easy. And see here, one important restriction is there in this method. If the displacement or the velocity, that means if the displacement is given in separated intervals, that means from 0 to L, it will become, for example, 0 to L by 2, the displacement is something, and from L by 2 to L, the displacement is another. So in that case, it will be difficult to apply the D'Alembert's equation. Okay, so for that, you can move according to general method. So, and first of all, I have derived the general method formula. Okay. So after that, I'll do some problems based on general method. Okay. So if you have any doubt, then please ask me. Wherever you'll have any doubt, then you can ask me. Okay. So wait for my next video in which I derive the wave equation, solution of the wave equation. Okay. So till then, bye bye.